Okay, so in this video I'm going to look at functions, and I'm just going to look at the basics of functions, what they are, how they work, and the definitions of the words that we use around when we're talking about functions. So first of all, what exactly is a function? Well, a function is basically an algebraic expression where we put a number in and a different number comes out. You can think of it, if you like, as some kind of, let's say, a machine, and we're going to stick a number in here. Let's say we stick the number. This is where we put the number in, and the number and another number comes out this side, and there are various, I don't know, cogs and wheels in here, and let's say we put the number 4 into this machine, and let's say the number 8 comes out. That's basically what a function does. You put in a number and you get a different number out the other end. So in this case, what's happened to this number 4? Well, it's doubled, or we've added 4 to it. So 4 plus 4 will give us 8, or 2 times 4 will give us 8. So this machine could be the function, the doubling function, or it could be the function where we just simply add 4. Now, we can have, let's say, two different machines, two different functions, if you like, and let's say this is the squaring function. So we're going to, whatever we put in, we call it the input, we're going to square it. So let's say input squared. So these functions here just involve squaring whatever number we put in. So the number that we put in, let's say here is -2, and let's say we're going to put in 2 here. Well, what output will we get here? Well, if you square -2, you'll get 4. If you square 2, you'll also get 4. So you can see here that we can put different numbers into these functions here, but we'll get the same output. We'll get the same output. These things here are called outputs. Output. So we put 2 different inputs in, and we have 1 output. So that's how functions generally work. Now, let's just look at ways of representing functions. One way we can represent them is using what are called mapping diagrams. So, for example, let's say you have your input and you have your output. So these will be our inputs, and this will be our output here. So let's say we take I don't know, 3, 7, 9. So these are the numbers in our inputs. So we're going to put these numbers into some function, and let's say we I don't know, we get out let's say 9, 21, 27. So you can probably see what's happening to our outputs. Let's say this number 3 here is mapped onto 9. Number 7 is mapped onto 21. Number 9 is mapped onto 27. And this function here, we'll call it the function g. Usually you will call these functions f or g or h. You'll give them some letter just to, it refers to they refer to different functions. So this is our function g here. So the 3 will be mapped onto 9, 7 will be mapped onto 21, and 9 will be mapped onto 27. So you can probably see here what's happening. Each of our inputs is actually multiplied by 3. So the function g just multiplies our inputs by 3 to give us our outputs. So this is this thing here is a way of representing functions, and it's just called a mapping diagram. Now, you'll notice as well that each input is mapped onto an output, and for a function to be a function, if you like, each input can only be mapped onto one output. So for example, if you have let's say another function here, let's call it f this time, and you have, let's say, 3 numbers here, and we'll say this is 1, 3 and 7, and we'll call this, let's say, 4, 6 and let's say 10, for example. If this function f, whatever it does, let's say it maps 1 onto 4, and let's say 1 is also mapped onto 6, and let's say 3 is mapped onto 10, and 7 is not mapped onto anything. Now, I said that this was a function at the beginning. In fact, this is not a function. It's not a function because one of our inputs here, 1, has been mapped onto 2 different outputs. So this can't be a function. You can't have one input mapped onto 2 different outputs. So you can have, for example, if I draw another mapping diagram, let's call this one H, and you've got 3 inputs here, and let's say 3 outputs here. You can have this input mapped onto that output, and this input mapped onto that output, and let's say this one is mapped on here. Now this is a function simply because each input is mapped onto one output. So this one is mapped onto this one is also mapped onto this one is mapped onto this one here. So this is classed as a function. Whereas this up here, this f here, is not a function because one of our inputs is mapped onto 2 different outputs. You can't put a number into our machine or into our function and get 2 different numbers coming out the other end. You can only have one number coming out for each individual input. Okay, so that's our mapping diagram. Now you can also write functions as couples, if you like. So for example, if we take this function g here, g is just the function that maps 3 onto 9, 7 onto 21, 9 onto 27. So we can list the function couples. So we can list them like this. This is 3, this is 9, this is 7, and this is 21, and then we've got 9 and 27. So this is another way of representing our function g. This is our function g here. So 3 is mapped onto 9, 7 is mapped onto 21, 9 is mapped onto 27. So that's 2 different ways of representing functions. Now let's just have a look at another way. We could represent a function by drawing a table. So we could have our let's say our input here, and let's say we double the input, and we're going to add 1. So that's what we're going to do to our input, and then we've got our output here. Now you can draw a table like this, and let's say that we put in some inputs and see what happens. So let's say we put in the numbers 1, 3 and 5. So these are our inputs, these are our outputs, and this is what we're going to do to our inputs. So 1, if we double it, we'll get 2, and then add 1, we'll get 3. So we're going to say we're going to double it, so we're going to say twice 1, and then we're going to add 1. In this case, we're going to double 3, we're going to add 1. In this case, we're going to double 5, we're going to add 1. So what happens? 2 1s are 2 and 1 is 3, so our output is 3 here. 2 3s are 6 plus 1 is 7, 2 5s are 10 and 1 is 11. So you can see here we have our inputs. 1 becomes 3, 3 becomes 7, 5 becomes 11. And we could list them in pairs here, or couples as well if we like. So we can just write them as 1 3 3, 7, 5, 11. So that's another way of representing a function. Now, just to go through some definitions. So our function, generally, as you've probably gathered at this stage, a function is just simply, it changes an input into an output according to a certain rule. So we put our input into our function and we get our output out. So let's just look at some definitions of some words that you're going to come across when dealing with functions. So the first one is what we call a domain. So a domain is the set of all possible inputs. So the domain is it's basically all the numbers that you're going to put into the function. It's a set of all possible inputs. The next one is called a range. And the range is the set of all actual outputs. The range is also known as the image, if you like. So you can you put your objects into the function, you get your image out the other end. So the range is the set of all actual outputs. And the last one then I'm going to look at is what's called a codomain. So the codomain is the set of all possible outputs. So let's have a look at how that actually works. Let's say we have our inputs, we have a function here, we have our inputs, and again we have our outputs. So these are our inputs here. Input, output. Now, let's take some points here. Let's say 1, 2, 4, 7, 9. And let's take some numbers here. 5, 7, 11, 12, 20. And we're going to map, let's say, 1 onto 5. We're going to map, let's say, 2 onto 7. We're going to map, let's say, 7 here onto 11. And let's say we'll map, let's say, yeah, okay, so we say we map 9 onto 11 as well. Okay. Now, so what's the domain, what's the range, and what's the codomain in this particular case? Well, our domain is the set of all possible inputs. So the domain is the set of all possible inputs. So our domain in this particular case, the set of all possible inputs will be 1, 2, 4, 7, and 9. All the possible inputs. What about our range then? The range then is the set of all actual outputs. So in this case, what are our outputs? Our actual outputs are 5, 7, and 11. So there are our actual outputs. And our codomain in this case, the codomain then is the set of all possible outputs. Well, these are all our possible outputs here. So we've got 5, 7, 11, 12, and 20. So that's our domain, our range, and our codomain. Okay. So they're just some definitions that you'll come across when you're dealing with functions. Now, how do we identify functions then in terms of, well, I mean, we said that a function can be called f or g or h, but we usually write it using mathematical notation, and we usually use the letter f initially, f for function, but as I say, you can use g or h or any letter you like really, but we usually start using f initially. Now, the way we write our functions, let's say we're going to double our input and add 1. So our function is going to be twice a number, and then we're going to add 1. Now the number that we're going to enter, we're going to call x. So it's going to be twice x plus 1. So x is our input, we're going to double it and we're going to add 1. And the way you would write that is like this, f of x. So our function is called f, and this x here is what we're going to put into our function. So this is called f of x. So for example, in this case, f of, let's say, 3 would just simply be 2 times 3 plus 1. Instead of the x, we're putting in a 3. So instead of the x here, put in a 3. So 2 times 3, 6 plus 1, 7. So our input is 3, our output is 7. And we would usually call the 7 y. So you'd notice from coordinate geometry, if you look at those videos earlier, that if we wanted to plot this, our x we said here was 3 and our y is 7. So if we want to actually draw this graph or this function, our first point could be 3, 7. We'll go into that in another video. But initially what you've really got to understand here is that we're calling the function f, we're putting x in, we're going to double the x, we're going to multiply it by 2 and add 1. So if you put a 3 in, if our x is 3, we're going to double the 3, add 1 and get 7 out. So our y then is going to be 7. So in other words, our f of x, another way of writing f of x is just y. And we can also use mapping notation as well. And the way we usually write that is f x and then an arrow like this. Okay. So when you see a function, say for example this one here, it can be written like this: 2x plus 1, y is equal to 2x plus 1, or just simply 2x plus 1 here. So this is 3 different ways of writing the same function. F of x, y is equal to, or f of x is where x is mapped onto 2x plus 1. So if you see these notations here, they just mean the same thing, and you can interchange them. Okay, that I think is about enough for the moment. It's just the very basics of functions, how they work, some of the definitions, and some fairly simple examples. So I'll do another video on more advanced kind of functions later on. You can have a look at that. Okay.